Okay, welcome, Michael Wickerson at Wickerson Studios. I am about to show what I've been working on this week, which is on wickersonstudios.com. Math is Too Beautiful, the Wickerson Way. And what I put together very quickly yesterday was an understanding of teaching myself calculus, kind of 101, a little bit of an intermediate, and a little bit of an advanced. This is all available on the shop. I have 2 items, small repos that I'm working on, and then I tuck them into this master repo site, which has well over 150 full repos. So, getting started, what you'll want to do, and actually I can jump back into here, is you want to be working off of ChatGPT. And most of my work begins, if we look into here, with a simple prompt like teach me calculus geometrically with Python 3.0 node editor and Grasshopper for Rhino in 100 easy steps and scripts, starting with the first on one, I should say one, and output points, curves, geometries in Grasshopper node editor. And it does that. So all you have to do is start stepping through with your prompts, fixing bugs as it goes, and you can see that this just flies through and generates code faster than I could ever imagine until I get down to the final section where I'm actually now create a script that teaches me advanced calculus techniques in Grasshopper, and I think I was onto the 20th script by that time. What I do like is the GPT-4o with Canvas, because you can step up and see it updated right here. You don't have to watch it all print out again. You'll see it run over and change the script as you go. One of the fastest ways to learn coding, in my opinion, and learn how to bug and learn really well documented code. Some of these scripts get up to about 300 lines, but otherwise they stay under 100 for the most part. So we're not going to spend too much time on that. We're actually going to jump in. And what I have is file, open file. I have all my files here that I've made. Probably takes about 3 to 5 minutes to make each one of these scripts. And we can start with the Wickerson way and open that one, which you saw was already opened. Now, it took a few tries, and you'll see what I put into the script as I open here. I like to take the node editor, so the terminal down, because it's going to come out on my math scripting node right here in Python 3.0, so that's fine. And I'll just have to set inputs and set output names correctly. And I will take that script and throw it down here so I can see it. So I'm literally looking at my visual outcome of the code in Rhino. I'm looking at my in this one, since it's 2D to start, I can just look at the top view, and you'll see that I put it in an XY grid. I put my point on it. I have my text. Actually, this one I didn't even do the grid yet. The first version was so simple, it output a geometry curve tied to the function that it decided to make, a quadratic curve, and then I have control over the position. And you'll see this one, I just have to hashtag out the parameters that I want to have control of. And I've set those parameters by going in here and choosing type set and access. And now I should be able to, with the point geometry, you'll watch the orange dot, should be able to move that along the curve. It's updated its scale, and you'll see that that little blue dot will analyze that curve from -2 all the way up to 2 and flow along that curve. So that was a pretty basic system, and then I can actually change the curve, change the quadratic by moving it around. If we keep an eye on that, I can shift the where the root is. I actually have it snap to 0, so it'll actually jump back to that, and then I can end the front as well. So you can do some pretty interesting 2D adjustments to your quadratic, but that's it. And the outputs, whatever's output here, out curve, out points, out grid lines, out labels, that's what's being put out here. And actually, it's only, I have to make sure these texts are actually going to geometries. So to update this is actually a good idea. That should output the grid, and that comes in the form of lines, and this should output the points on the grid. So now everything is in there, which is great, and I can focus in on anything I want. So that's it. I fixed it. I'm going to upgrade that, save it, and you can quickly get a sense of calculus, have a nice 2D model, and move on to the next one. I sell all 24 of these, I think, for $9.99 right now, and after I get them up to maybe 100 to 124 scripts in calculus, I'll tuck them into a repo valued at about $10 in the larger versions. So if we go here and we open the second one, I think what I did here was I actually just put in the grid lines, but you'll see that advancing the script by asking it to advance, it basically put a tangent on there at the point of what's happening. So the second one's pretty much the same setup. This was actually to the other one, so you have to go in here, and the only problem is you have to downsize your terminal, size your window to where you want to put it, and just tuck it down here, and you should be all right for your reading your code. And that's it. And looking at this one, I'm going to, sometimes it sizes one way and not the other way, which is kind of a pain in the butt. But as I go back up to my, you'll see that I did hashtag out the defining variables, t at 0.5, which gives me an idea where to start it, and ABC at -2, 0, and 2. I've taken it back down to -3, but you can still play with that, and you can still play with your point and your tangent, and if you just want to see your tangent move along the curve, you can do that. So it just steps up as we go, and the whole system is about learning the code a little trickier. The final script right here for create curve for grid lines is actually the longest part of the script. Otherwise, it's about 60 lines of script, and without that, it would only be about 30 lines of script. And it's kind of like defining a point on curve script, and you can see the breakdown of that and get behind it. So you don't have to be focused on here and using all these nodes that are pre-packaged functions for you. You can understand the world as basically everything in the world, including yourself as a person, is a function. It takes inputs and you produce outputs. So let's just go on and we'll jump to the third one. Let's see what happened. It produced a secant. So I have a T1 and a T2 that I can adjust and learn a little bit about secants and how to script that differently in Python. And we just keep clicking through this. The next one put on, what was this one? Grid lines, point tangents, tangent point lines. So T, that one is doing the same, but it put on an indicator of what the slope was. So it wrote into it a text. You could see create the tangent line text, and where was that? The grid lines, you can change the size of your grids if you want. And just taking a look through, output curves, there's the text labels. There's the XY text labels, which were there. I'm just wondering where my slope form was, and if I can't find it, I'll probably just do a Control F in here, Control F, and just do a search for slope and see if that comes up. And maybe it's capital S. No, I don't want to do that. What am I doing? Let me get rid of this. Somewhere tucked in here, if I go through it, I might want to look at it. Evaluate the parameters. This is the text, but these are geometries as well. And these are geometries that are coming out here, but I can't select them when they're text. So once again, I probably would want to just update that from text to geometry. My curves out and my point and my nodes out. And then I'm trying to find, there it is. That's my out slope label, and that's right down here. And I think it comes in the final version. I think they just calculate it right here. Out slope label. That's funny. I guess I added it in, and then it's not. Oh, I'm so foolish. I'm not looking at the script that was here. I just told you about that. It will leave. That's the one thing about I don't like about the Python nodes and the node editors. They stay open, and then you'll be looking at another script, changing it. That's on a closed file. So that's a little, yeah, that's a little thing that tricked, and that's why I couldn't find the slope label. As I go down, I'm kind of thinking to generate it right here in the final thing, but the slope label was designated in step 9. So you really are just watching this through different steps, slowly making more and more geometries as you go. And the slope label is kind of a nice little thing to see how they made it anyhow, that it's a slope label position, and then it's got a formatting for the slope that's put in, so you'll learn a little more about Python as you go. And these scripts are just great for learning that. So I'm probably not going to jump through every one, but I am kind of keen. I haven't done this yet. So slope 5, without going into detail, it's got the slope label. I think I just had that one open. 6, this is something that I wanted to have inflection points, and inflection points I wanted to produce a more complex script. So the script that went in is this one, the points that are driving it, but you also have control over that. You will have to watch the number of points, because with not enough points you won't get the inflection points. And I put inflection point labels on as well, so you can really see how you can alter a more complex curve, and this might get you thinking about curvature analysis and thinking about when am I going to have to step into 3D form, which is exactly where I ended up going. So I'm going to open 7. This is putting tangents and a tangent count at how many points I want to do, and this is where it just gets one step higher than another. So keep an eye on this, that I have a tangent points count, and then as I jump farther up, and I'm going to go a little ahead, because all these are here, I'm going to go all the way up to 10. You'll see by 10, I've actually added some curvature segments, area curvature count for the rectangles. So if I bring that down, you could start to estimate the curve, have control over that curve and its inflection points, and you start to find the integral of those values, which is pretty cool. Just find the area underneath the curve. And that point, when I got to 10, I was like, okay, how can we start moving this into 3D shapes? And that's exactly what I did. And in doing that, I moved over to isometric, or I moved over to perspective view with the correct labels, with the correct grid lines, the revolve volume, the tangents, the inflection point labels. Put everything on here. And sometimes with vectors in Grasshopper 1.0, you're going to have to put on, I had to find my midpoints so I could anchor them, and then I could make my tangents, not tangents, I could make my normals coming off that curve, which is kind of nice. And you can see that those are the tangent lines, and then I've got 11, but I could always break that down to less and just count up what I want. That's pretty cool. And that's everything I need, everything labeled. And I've actually done the revolution in the y-axis. You can see if I take a curve and I do something foolish, maybe that wouldn't make as much sense. If I went in here and set my axis revolving in the z, you'd see that this just spins in a huge circle of rotation. And I'm wondering why it didn't. Hard-coded, slope, running. Very strange that it did that. Rotation angle z. Should have updated. Once again, I am being foolish. I am looking at what I'm doing, and I made the exact same error that I make like 100 times a day. I've got to get my forms down. So now as I update this one and run it with the z instead of the y, you'll see what happens. If I take that and move that to z, okay, and then update that, and then run my script, why is that not working on the revolution axis? I've got my form. My revolved axis should be there. I would think that it would, well, it must be spinning. Where are my revolutions? It's just doing a 180. It's not building the volume. Anyway, I'm going to leave that because I thought that was going to do something different, and it didn't. Rotation axis is Y. I could change it to Z, or I could change it for X, that matter, and get a totally different form as well. I actually wonder if I change that to X, if that would update, run. Why is this not doing it? Well, it's confusing me. I'll have to think about it. I'm sure somebody will correct me on my video notes. I'm going to leave it at that. I'm going to close that one. And then things get pretty wild because I go in and I start to blow things open with more complex geometries. So this is a nice form that I can play off of. I can extend that out so it becomes much larger or smaller. I keep my numbers kind of small. I can use my scaling factor. And then I can also pull my vectors. And you'll see as I go farther into it, opening up, farther down the line to 16, you'll see that I really have started to add a lot of vector displays, which have come in the form of Laplacian vectors and divergent vectors. So I'm just letting GPT generate, if we went back into it, more complex scripts as I run down and asking it to do more advanced geometries. And it's writing these scripts in a heartbeat. Back here I was writing it in GPT 4.0 without Canvas, but what I like about Canvas is you can open it up and you don't have to see it generated here. By the end, you're just putting your comments in and watching it update over in Canvas. So that's a really nice aspect of it as well. Anyway, so that was 16. Let's jump up to open new and go all the way into 20. If anybody wants to see this and see the scripts, this is a nice one, so it's getting a little more different. I've got the Hessian vectors, which are making much more for a more interesting geometry. And as I take that geometry up, you'll see what it starts to do. And then what did I do after the Hessian forms? I didn't label them here, and I probably should have. Let's go into 2. There we go. We start to get some more funky grid work that we can separate out. And these also have a wonderful contour line for slicing that I've added to it. And I took that count up too high, so now it's trying to really explode in all different directions. It's thinking, and it's running its course through all of its complexity, and hopefully I didn't bug it out, which happens periodically. But there we go. We've got it up to 4. And I think maybe I'm going to have to reset because everything seems to be humming away. and thinking too hard. I have to be careful on my sliders, and I'm not. Oh, I keep thinking that's the, yeah, there we go. It upgraded, but you can see that it really explodes off in a direction at 10. So there's no point to have something set so high. So I'm going to bring back down to 5 and just have that be the max. It's still going to process for a few seconds. There you go, and I can bring that count down to maybe 2 or 3. And I can do my favorite zoom extends all, and I can also take a look at it in how I enjoy viewing all my work. Zooming in here, I will probably take that to artistic, that one over to pen and ink, this one over to X-ray, or actually shaded. Actually, render will cut off the bottom, so it look like it's emerging as kind of a kind of like islands through water, which is kind of nice because you get the construction plane that cuts it off. And you've also got through that your analysis of your contour lines to think about what you're doing with this form. So you could carry this into ideas of kind of descending the gradient and finding out your roots and finding out where things are flat. But right now these are pretty simple scripts. I think the ones I end with, open, I was having a little trouble with O3 here, that I just wasn't generating my my curve point intersections because I wanted to start doing booleans and volumes analysis on things. So if I jump into this, the last one, I think I did get it to work in a very basic level with certain geometries, and we'll let the volume calculus triple integrals start to take effect. And I'm right here at 24. I'm enjoying it. I think it's kind of a cool form that comes from a graph. What I basically have is all the intersection, and I don't have things being very parametric. Like as I look at these shapes that are cut through, and then I look at the geometry. Should be these ones, the curves of points of intersection on that. This is going to get more complex when my functions get more complex. Right now my functions are tied to pretty basic shapes, toruses, cylinders, and spheres. So I'll make that more complex as we go. Anyway, that's Wickerson's studio, the Wickerson way in a nutshell. Teach me calculus. And I'm going to just say thank you for watching.